See, that's me right there. That's me. See how fast I'm going? Yep, I remember doing that. Hey folks, welcome back. I'm going to redo the regulator repair that I did in an earlier video, which I will link to in the description, to make it better. There's a couple problems with it that I will show you as we go along here. One of which is it backs all the way out instead of it stopping. So we need to fix that, and it's kind of loose. So, you know, the last repair I made, I believe I made a bolt and then tapped it for a larger size. That bolt was a larger size to match that tap into the housing itself of the regulator. And, you know, that's steel into aluminum, and this aluminum is pretty much, you know, peanut butter material. So I need to do it better. I have an idea how we can do it a lot better, and we're going to go ahead and do that. A viewer commented on the other video and suggested doing something like this, and that's the repair they did. So I'm going to go ahead and emulate that viewer's repair in this video here. So the first thing we're going to do, of course, is safety third, unplug it from the wall. I'm going to wheel her out off camera, we'll drain her, and then we'll go ahead and take out the, we'll take all this apart here, which is really easy. And then we'll get the regulator out, go over to the bench, and then we'll take a look and I'll explain, if I can remember what I did in that last video. Again, watch that video and probably easier to do it that way. We'll go over that really quick and then tell you what I'm going to do to make it better. Mo better. Air is all drained, and when you do that, you definitely want to wear hearing protection. It's extremely loud. So again, safety third. Now the way this is set up is the regulator is mounted to this front panel. These 4 screws here, which should be 8 mil or 5/16, hold the panel on. Then you have 3 screws in the middle that attach the regulator to the panel. I'm going to take those off first, and then that way it's separated from the panel, and then pull the panel away. That just gives you access to everything. Oh, I forgot there's nuts on the back side of those. Ah, nuts. You can run, but you can't hide. Then all there is to it is to take off the main line that comes into your manifold here from the shutoff. This is the pressure relief down here, which is, you know, when it goes to shut off, it'll relieve the head pressure on, you said head, on the compressor. So it doesn't have to, it doesn't try to start against a, you know, a load, that there's back pressure against the pistons in there. So that's what that does. So I'll disconnect this line here, and then we'll take it over to a bench or something. We'll start taking it apart and see what's going on inside there. And then I'll refresh my memory as to what exactly I did on it. I guess I could just watch the video, but that's too easy. I don't remember how I did this last time, but we'll use Dad's old bench's wood jaws here, because it is a wood bench. You said wood, and so we'll go ahead and unscrew the regulator portion from it if I can. I remember how I did it, to be honest with you. There it goes. Looks like I must have used some sort of sealant in there, thread seal or something. It's getting longer. Alright, so inside here is the actual valve that gets adjusted and opened all the way or partially, or however much you want as far as to regulate the air. And it does that against a spring pressure, which is inside this guy. So this guy goes inside there, and this guy goes inside there, so the spring is pushing up against this plunger. Alright, so this plunger's got a little O-ring on it, and looks in pretty decent shape. And then of course the body itself, which is what we're going to work on, is got an O-ring as well. And so all you're really doing when you turn this thing in is pushing against the spring, which pushes against this plunger, which pushes against the valve and opens that valve up, which apparently must have some sort of a either, I don't know if this has got a spring or anything inside of it, to be honest with you. It may just react backwards based on air pressure. In other words, the resistance against the spring is the air pressure from it's coming in from the tank. I don't know. That really doesn't matter, because we're not going to get into this. The main part is in the control side of it here, or the adjustment side. And this is what we worked on last time. So I just got to remember what exactly we did besides dropping crap on the floor. We take an inside look at this, or look inside rather, we can see what the problem is. I remember now, I put a screw on the inside of that shaft, on the other end of the shaft, which is a positive stop when it comes out, and it won't go any further. The trouble is the screw is loose, as you can see, besides the part that I'm hitting the camera here, the phone. But the screw is loose and it shouldn't be. And so if we bring that all the way in to give it some clearance, should be able to tighten that up, and that would solve that, which it does, but it's coming loose. I'm gonna have to come up with a better, you know, a better option. I don't know if it's just Loctiting it with a better Loctite is or what, I don't know. But yeah, and I have a couple of washers in there which they don't even look like they fit properly. So yeah, this is what we're gonna work on. So I'm gonna take the screw out again, this one, and then we'll you know, back the thing out all the way and take a look at those threads, and then figure out what we're going to do based on what I did last time, I guess, which was the fix. And I can't exactly remember what that was. Oh yeah, that's right. What I did was I think I made a new shaft that goes in here, a new screw, I should say. I'm pretty sure. And I remember heating this up and taking it, the old one or the other one out, and then I tapped it bigger, which I think I tapped it to, I can't remember if that's an M10. I think there was an M8 in it, and I tapped it to an M10. I'm not really sure. I'll have to go measure this. Yeah, I think there's going to be a little bit better way to do this than the way we're doing it right now. Because again, this is kind of loose. It's definitely much more sloppy than I remember it being. It would probably work for quite a while longer, but being this is, you know, Chinesium grade aluminum, I just can't take the chance of this crapping out. It really should be some sort of a steel insert, similar to a you know, a helicoil or something like that. So this will be easy to solve on the end. I'll just do a better job on that. Maybe use a washer that actually fits. But this is the main thing. So let me go refresh my memory and measure it up and see, you know, what it is. All right. Now that I know what I did, now that I know what I got to do, I'll tell you what both of those things are. What I had done was, whatever this was before, M8, I drilled it out and tapped it to M10 1.25 thread pitch. You can tell it's a 1.25 thread pitch because I didn't even measure it with a pitch gauge. I put it at 1.25 M10 bolt and it threads right in here. This is a Time-Sert kit, which is M10 by 1.25. My plan is I'm going to put a Time-Sert in this, which will of course go in from this end, and it'll be a permanent repair. The problem is this Time-Serts are too long. Essentially what you have here is only a very small area, about that thick. I couldn't exactly tell you what it is, maybe about 3/8 of an inch or another 10 millimeter. So maybe about from here to here, and this is considerably longer than that. And the spring, unfortunately, has to go directly up against that surface, so it won't fit around the Time-Sert. So therefore, we have to cut Time-Sert down. Now, these Time-Serts have an area at the end, which is kind of a non-threaded part. You can kind of see that right there. It's flat, and when you put the Time-Sert insert tool in, it spreads that out into what you're putting it into, and helps hold it in. So we're going to grind this shorter, and it won't have that, but it's still going to be fine because it wouldn't be any different than like a helicoil. And we're going to use the 60-20 Time-Sert red Loctite, and we'll put it in with that. But I'm going to have to try to get a better measurement on how, you know, deep this is. Deep. And then we'll cut this off to suit. I'm not sure if you can turn these. I never tried, but probably just grind it off. And because these are, you know, these are steel, but they're not freaking super hard. So I could probably put it in a lathe and turn it down. Might try it, I don't know, because I got a couple of these. But these Time-Serts are very expensive, so I don't know if I want to waste a couple of them experimenting. But yeah, that's what we're going to do to solve this. Now, as far as the end of the shaft here goes, we're just going to do a better job Loctiting that in. You know, that's the only thing I can really think of as far as this thing goes, because again, it's got to have a screw. Well, it didn't have a screw before, I don't think. I don't know, but it's going to have to have something in there that's not going to easily back out when you come to the end and bottom it. So essentially it's bottoming against the inside of this, and therefore it can potentially unscrew this. The best thing to do would be to put a left-hand thread in this thing, but unfortunately that's too late, and I don't have any left-hand taps anyway. I've got left-hand drill bits, but not taps. So we'll come up with a better solution for that somehow. I'll think about it. And then, yeah, let's just get to work. We'll go ahead and let me measure this out, see what that thickness is, and then we'll cut one of these down, clean everything up real good, get it in the lathe. We'll put the that Time-Sert drill in, and then a Time-Sert tap, and then we'll go ahead and install it with that Loctite, like I said, and this will be pretty much a permanent repair at that point. Because, you know, the one thing we definitely need is we need something that is not going to wear out like this aluminum, and these Time-Serts are definitely not going to do that. Since we got the right ones, let's go ahead and use them, you know. Now we're going to go ahead and get real anal for you here. Real anal, like anal to the 20th power. Because if you want to measure something, you might as well measure it right. And so what I'm going to do is I'm going to take our little temporary vise here and hook it up. There we go. And we're going to take this guy and put it in here. And see that surface down there in the bottom, that shoulder where the spring goes? We're going to take it and we're going to measure it from here to there with a depth mic. Totally unnecessary and completely just over the top anal. I had to put the 1 inch or the 2 inch rod in. You said rod. And so that we have to add an inch to this because it's a little deeper than the one that normally goes in there where it's 0 to 1. This is 1 to 2. What that's showing us right now, it is 1 inch and what is that? 75, 82. So 1.082. 75, 80, 82. Yeah, because this would be 85. So 82. 1.082. Let's double check it. These depth mics can get confusing because you're reading them backwards, basically. Yeah, so 75 and 5 is 80, 82, 83. All right, something like that. 1.082, let's say. Then we'll do the overall distance with a pair of calipers, a stair at 120s. So that's 1.380. So that's pretty close. 1.0, let's round it off to 1.080 to 1.380. That's a 300 thousandths, basically a 300 thousandths width as far as those threads in there goes. So that's what we got to cut this one down to, is about 300 thou. Probably will be perfect then, because we don't want it sticking out really at all inside there. And yeah, if you don't have one of those tools, you can do it by eye or whatever, but since I'm an anal son of a gun, we figured we might as well use them. Yeah, of course I'm going to try it. Cool. Now I'll tell you right now, these things are pretty brittle, so if I was doing some sort of a precision repair, I would simply order the correct length. But that's at 400 thou. We got to take 100 off. You got to go from the top where that lip is, or I should say that flare, because that seats down inside that aluminum a little bit. We have a special tool for that that comes with the kit. It's a counterbore tool. I'll show you each step of it, because that'll be the same if you're doing any Time-Sert work. But like I was saying, this would definitely not be something I'd be doing in a precision situation. I would order the right Time-Sert. I need a pair of those mics or calipers that have the very narrow outside jaw, because the problem is I can't get in behind these things. I need to probably order a pair. Find them on Fleabay, get a nice Starrett or something. Alright, I got a little bit more to do, and then we'll clean it up, take it over there, and I should say we'll actually bring the other parts over here and do that, but it's almost there. We're going to make it 300 thou from the outside to the inside. Yeah, so whenever you're doing a Time-Sert, first step is, procure the proper Time-Sert kit. Here's your M125 kit. They are very, very expensive, these kits, when you buy a whole kit. And like that spark plug repair kit for 14 mil was like 260 bucks or something for the kit. But I don't remember how much this was. But it's a really good kit. I've only used it a couple times on the VFR, actually. replacing some M10 bolts in the engine mounts that were completely galled out, and they work perfectly. I did it on the mill. I have that in a video too. So what this kit consists of is, of course, your inserts, the tap, which is here. This is a counterbore tool, the drill, and a insert installer tool. That's what this is here, M10125. Now the order of operations here is, of course, we drill it out first, okay, and then we counterbore it with the counterbore tool, and then we tap it. And what the counterbore tool does, it gives you some relief for that little top edge you can see right there, that flared area, so it will seat flush. The way the counterbore tool is made, you can see that it has got a certain amount of cutting surface, but then that cutting surface would bottom out to where it can't cut any further. And that's that outer edge right there, that outer part of the tool. So it can't go any further. That's non-cutting surface, so it's only going to give you that depth of that tooth, and that corresponds with the depth of, or a little bit more than the depth of this little flare.
We need to talk about your flare.
Get the drill in, shoot it through. This will be easy peasy. I don't know if these things have a starter thread on them that we just cut off. I kind of doubt it, but yeah, so that's what we're going to do. Now whenever you're using one of these, of course, you have to make sure that you have enough material on whatever you're drilling into. This has got plenty, so we're not going to have to worry about that. But if you had any situation where you didn't, you may not be able to do it this way, or you may be able to source a different type of a Time-Sert or different type of a thread insert that is designed for a thinner installation. I don't know. I do know that these work really well. And they're, like I said, they're ginormously expensive. So this is running pretty well. Chuck is clear. And you know, you don't need a lathe for this. You could easily do this by eye. It'd be close enough. But since I got it, I'm going to go ahead and use it so it's nice and straight. Let's go ahead and do it. All right. So that's our drill done. Nothing to it. Like I said, these Time-Sert kits are excellent. The quality of the grind on your drills and on that counterbore tool, which we're going to use now, is just superb. The only complaint I have is it's hard to get fat fingers in that little container to get these out. Other than that, we love it. Now I'm not going to use the tailstock wheel here over stage left, or stage whatever this is going to be, because I'm not going to be able to feel that. So I think I'm just going to go ahead and push it in on the tailstock itself, maybe. Let's try that first. Yeah, that worked good. So, all right, I'm going to clean that out and come back, and then we'll do the tapping, and then we'll put the insert in. Okay, that's really the way it should look. I had a really good rolled over burr right there, but I just went in by hand here with this counterbore tool, you know, my brain, and cleaned it up. So again, you got a nice counterbore relief in there for the end of that flare on the insert, okay? And that's what stops the insert, of course, from going in any further. And that's one reason why I wanted to use it in this application, because although we're not probably going to get really good spread because we cut that insert down, the red Loctite's going to keep it from backing out, I can guarantee it. Guarantee it! But this way it'll keep it from going in because it's got a flare. So yeah, don't forget your flare.
We need to talk about your flare.
Like I said, this stuff is gummy. It's like the bologna of metal. This is like pot metal. Like bologna is the kind of meats all thrown together. They mix together to make bologna. Well, this is kind of like what they do with pot metal. They just throw whatever metal they got laying around and throw it in and make some crap metal. It's really gummy. It's a piece of junk. But what do you want from Chinese? So anyway, this will be ready to chuck back up, and we'll run a tap through it. I'll show you how crappy this stuff really is. Take a look down in there. You see that porosity on the inside of that bore that I just drilled out? That's not damage like from somebody hitting it with a hammer. It'd have to be an awfully small hammer, said the wife. That's just crap metal. That's why these things are stripping out and failing, because like I said, it's being made out of bologna or certainly peanut butter metal. So yeah, that's the reason why. So I think the insert is definitely the way to go on these. As far as a repair that's actually going to last. And a viewer mentioned it in the other video about, I believe the viewer said he had the same air compressor and then fixed this with a helicoil, which is fine, as long as you can Loctite it in place. Because again, the helicoil doesn't have a flare on one end, so it's going to have a tendency to want to go all the way through or back out, perhaps, certainly all the way through, assuming a right-hand thread when you turn that regulator in, which you definitely don't want. Alright, so what we're going to do now is just put the lathe in back here, and we'll run this tap in, and then it'll be good to go. And then we'll put the insert in after cleaning it with some red Loctite, with that insert installer tool. We'll do it in here as well. And then you don't need to, though. I mean, you can do it by hand, and we will do that part by hand because the installer tool is set up like a tap, and so you can just put it in a tap driver. You can put it all, of course, the tap itself in the tap driver as well. Hell, you can probably put the counterbore tool in there if you wanted to, and just do all that by hand. So it's very versatile. Alright, there's the Time-Sert driver and a tap wrench. We're not going to turn the tap wrench, we're going to turn the chuck. And it says to use light oil, so I just used a little 3-in-1 oil on it. And then we're going to put some Loctite on the outside. You don't need to use this, for a repair like this at least. You really don't need to use the Loctite 60-20. But we're going to do it. We're going to put a generous amount on that. And then we're going, you could use regular Loctite, doesn't really matter, like Loctite Red or something. And then we're going to get her started, and hopefully it'll work. But cutting down this insert, I don't really know what the result's going to be here. We're going to have to kind of do it as we go. I'm sure it's not going to be as tight as it would be normally when you do it, but we're going to see, because I don't think it's going to tighten up at all because we don't have a bottom part of the insert. No, we sure don't. So now we just have to be very careful when we take it out it doesn't back out, because normally that would be super duper tight in there with the installation tool, and that's most likely because we cut away that feature on the bottom of the insert, this one right here, that has that reduced section that kind of bites at the end there. All we really want to do is get this in with the Loctite, though, and be as tight as we can. It's about all we can hope for. I thought I was able to get that to turn by hand here, but it is bottomed up. It's much as it's going to be. It really should be in a lot further. But again, because of the situation we have by cutting that bottom of that thing out of the way, it's not going to be that way. What we could do possibly is get an M10 bolt and put a nut on it, but that nut's going to bottom up here. Probably it's supposed to sit down inside there a little bit more. Now, you know what we could do? Here, look at this. What am I thinking? Why can't we just run it all the way down to where that driving tool stops? Yeah, look at that. Then just push it in all the way, because this counterbore should be, or that flare rather, should be into that counterbore a little further. Why couldn't we do that? And get it nice and tight, like this. There we go. That's a lot better. So now it's seated all the way, but you don't normally have to do that. All you do is you do it until it gets tight, and then it gets loose again, and that will be seating it and spreading it, spread out inside there. But of course, like I said a couple times already, we cut away that feature on this on the insert. We're using them for something that they're really not designed to be used for as far as installation goes. That looks pretty good. Let's take it out and take a look. Not too terrible at all. And as far as in the bottom goes, maybe through a little bit more than I wanted it to be, but that's going to be fine. Not going to hurt it. I mean, worst case scenario, I could go in there, just chuck it in the chuck this way, go in there once it cured, the Loctite cures, and knock that away with, half-inch end mill or something, and even in the chuck, which I might do, just to tidy it up on the inside. You don't really have to though. I mean, it's just not that important. So the next step is we're going to go ahead and let this cure, let it kick for a while so we don't skew it up. But yeah, I'm okay with that. That repair is going to work pretty well. And we got it nice and tight because, like I said, I realized we can just bottom the tool out and push it all the way up in. Okay, folks, we're going to go ahead and put it back together. It's been some time has passed. I do have a little different setup, just a longer screw basically for that center part to hold that restraint in, which is just a little washer. I made a better washer, like a little fender washer for it. So I don't want to get any grease inside the hole. I just want it on the threads. All right. Next thing we do is we screw this in the hole, and it screws in real nice. That's a really nice fit too. I mean, you do have a little bit of wiggle room there, but that's because of I remember now what I did. I made this out of a bolt. I made it out of a bolt. And so that's just the way this is. In regards to the quality of the thread on that bolt in there. And darn it, I got a little goo in there. That'll be okay. Alright, so the next thing we do is we got to put, we got to put this in, which is that fender washer. And what I did was I took a carb screw, shortened it a little bit, and it's longer than what was in there though. So this is what was in there. So it'll be a little bit more thread engagement. Therefore, the Loctite will hopefully hold a little bit better. I wouldn't normally use it. I probably should use red Loctite, but if I ever got to get this thing apart again, it can be very difficult to do. So I'm going to go ahead and try blue Loctite again. We're going to get a good amount in here though, down inside the hole and on the what is this called, a screw. And then put it in, and again that just keeps it from backing off all the way. Next thing that goes in is this little dome shaped plate, which protects apparently that, or captures the spring on top of that screw, and the spring, and our little plunger dealio, which we'll put just a little bit of grease on it. Why not? Can't hurt nothing. With that side that goes down inside the spring. This little pointy thing articulates with that part of the valve down here. I took the O-ring out. Let me go get it because I cleaned it up, the body. Nice body. Put the O-ring back on gently. I'm going to go ahead and use a little 3-bond 1211 on this. I don't have any like plumbing thread sealer. I'm out of it. So I think I'm out of it at least. Might be out in the shed, but this stuff works pretty good if I can get some out of the tube. And put it back together. That's all she wrote. Clean up the glue, or the goo in this case. Goo, not glue. I think she's going to be ready to go and will be good for quite a while with a steel insert rather than running on the aluminum. So the steel threaded rod or bolt running on the aluminum versus this guy. I don't want to go too much with it right now. I want to let everything cure up nice. I will go install it and then we'll close the video out. Okay guys, see how we did? Got about 100 psi in it right now, and I didn't wait till the next day. I just gave it some time to kick because I need to test this out, get it into editing, and put it up on the channel. So there is one problem with it. I've already tried it off camera, but it's not a big problem. So we can turn it up and it's buttery smooth. It really turns very nice compared to before. Not gravelly or roughly or anything. We got equal pressure to what tank pressure versus tool pressure, so the regulator is opening all the way. The problem is in the closing side. Let me back it out here. When you back it out and you relieve the air pressure like it's supposed to do, it doesn't go down all the way, and that's because the screw I put in to keep this thing from coming out all the way is occupying, it's thicker, it's occupying a little bit more real estate than the screw that was in there, and thereby keeping a little bit of pressure on that valve. But it's no big deal. You can just, if you're going to change out a hose or something, it's going to pop off. 30 psi is a hell lot better than doing it at 120. So yeah, that's the only foul up, if you will, on this particular repair that I can report, but otherwise everything else works really well. Real happy with it. It's nice and nice and smooth, and it's going to be a good repair. Now, if you're going to use a helicoil versus a Time-Sert, you most definitely can do that. Use whatever size you want, like whatever was in there. I think it was an M8, go to M10. But if you're going to tap it and put a helicoil in, helicoil can go straight through. It doesn't necessarily have a way to hold itself in atop like the Time-Sert does with that little flared end. So what I do on that case, if I have a through hole, is I put some red Loctite on the helicoil, turn it in with the helicoil installation tool, get it down just below the surface, break the tang off on the bottom of the helicoil, then run a little bolt in or something immediately after that to kind of clear any red Loctite up that's inside the threads. You only want it on the outside part of the threads where it's contacting the Chinese peanut butter material in this case. And that way it won't dry up your red Loctite and then try to get your bolt in and it won't go in, or it's very difficult to get in. I've done that many times and it works real well. Just food for thought, or just a little tip there. Lastly, if you're taking apart this particular compressor, these 4 screws on the outside are shorter than these 3 screws on the inside. There's 4 like acorn nuts on the back side, enclosed nuts. So if you put a couple of these in by accident, you're not going to be able to torque them down because they bottom out inside the nuts. So use the 4 short ones on the outside, use the 3 long ones on the inside, put her back together, and you're good to go. All right, so there you go, folks. One Kobalt air compressor fixed again. I think it's going to be better, and I'm going to feel more comfortable about the reliability because, as I said, I need the compressor for my lift in particular. And if I got to get a bike down and I don't have a compressor, I can't get it down. So there you go. If you like what you saw, you know what to do. Definitely like the video, subscribe, ring the bell. You get notified when I put more crap like this up. Thanks for watching. We'll catch you on the next video.